Good morning, everybody. So we're going to be interpreting scatter plots and line of best fit, but this time we're going to be using a graphing calculator where we have our linear regression lines, and we're going to be using Desmos this time. So let's go over the steps. You're going to go to this website, desmos.com/calculator, so you can graph it. Then you're going to click the plus sign in the top left corner, and you're going to click you're adding a table. I will be showing you guys a demonstration on how to do this. I just want you to have these steps in your notebook so that we can have something to reference when you are taking this and doing this on your test. So enter the given values in the table. Click on the next section to enter a y1 with a little tilde, mx to the 1 plus b. You will need to use your keyboard, you guys, in order to get that tilde sign and some of those other values too. Use your, let me move my, so you're going to use your values for m and b to write the line of best fit. And then you guys are going to be able to have, so that you'll see that the R, there's an R going to be an R squared. We're only going to use the R, and it stands for linear regression coefficient. And you use this to determine the direction and strength of the correlation between the two actual values. So let me go ahead and show you some things about the positive correlation and negative correlation. We did already kind of review this, so we have dots that are increasing there on a positive slope. Then we have our negative correlation where the dots are decreasing at a negative slope, and then the dots are all over the place at no correlation or having a zero slope. So if our R is equal to a positive 1, that means that we have a perfect correlation, or it's a very strong correlation. And that means that basically our linear regression line is hitting every single point. Then if we have our value for the, then if we have our value for our R equaling, or our R is close to the positive 1, then it's like at like 0.99, then we still have a strong association, a strong correlation. If it's close to a negative 1, like negative 0.99 or negative 0.89, that's still a strong association. And then R is close to 0, then that means we have a very weak association and our dots are all over the place. So here, if we have our R equals 0.7, and we have, so since it's a positive, that positive 0.7, that means that we do have a stronger correlation. If we have our 0.3, that means it's a weaker correlation. And if we have our 0, R equals 0, that means that we have no correlation. If we look down here, we have the same number, but it's a negative 0.7. That still means it is a strong correlation because it is closer to a negative 1. So again, up here, the positive 1, that's totally fine as long as we are having those correlations that are closer to those values. So, and then if you look here, we have our negative 0.3, and our negative 0.3 means that we have a weaker correlation, that our dots aren't really matching that linear regression line, and then R equals 0, again, we have no correlation. So for our first example that we're going to go over, the annual profits for a company are given in the following table. So where X represents the number of years since 2014, and our Y is going to represent the number so the profit number in thousands of dollars. So we're going to go ahead and I'm going to walk you through this. Using Desmos, we're going to graph and write the linear regression equation that represents this set of data, rounding all of the coefficients to the nearest tenth. So make sure that you pay attention to that. And then these are the data sets that we are actually going to use. And we're going to plug this into our table. And so go ahead and write down your table now so you don't have to keep going back to it. And we will be able to enter this into Desmos and be able to graph. So I will show you guys what, so go ahead, again, write your table, and then I will move on. Okay, so now I'm going to show you guys on Desmos. This is your Desmos demonstration. So if you go ahead and click on or get into desmos.com/calculator, we're going to do that step 1 where we add our table. And we are now going to enter in those values in our table. So 0, 1, 2, 3, 4, 5. And then we're going to go over here to the right and type in the 104, 140, 159, 162, 166, and 170. So those are all of our table values. Now we're going to go down here to that next line where it says we have to type in the Y1. The reason why we're using Y1 is that's what our table of values says right here. Then we do our equal sign, And we're putting it in y equals mx plus b form so that we can actually graph it. So again, we're using our x values from our x table, and that's our table over here. Oh, nope, sorry, not equals. You need to do that tilde sign, so you can either use this keyboard right here. So we are going to go down to the keyboard right here, and you actually have to go, sorry, it wasn't an equal sign, so you need to do the tilde sign, which means you have to go to the ABC, and that tilde sign is right here. And you guys are going to then have that value right there. So now it reads it. If you put equal sign, it's going to say it doesn't actually count. It doesn't know what it's talking about. So we're trying to tell the computer to actually do a function here. So that's your keyboard down here in the bottom left that you're going to use. And you now need to go ahead and, so you have y1 tilde mx1 plus b, and this is where our r value is. And now we need to actually write our equation. So you see our lines over here. It already does have one. However, I'm going to zoom out so I can see where those dots are. And I now found them. So you can leave it zoomed in, and actually I'm going to zoom out one more because then you can actually see all of my points there. So our goal is to try and hope that we can match this line, and this is what we'll be looking for you guys, for you to be following directions. So we're now going to put our y equals, we're going to use that m for our slope. Please round to the nearest tenth. So we have 11.7 as our slope, and we have x, and then we have a positive 120.8 because we are rounding to the nearest tenth. So if you see that I actually have that line, so my line was originally black. Now if I put my line in here, it's blue, and it went directly over the one I actually found. So yay, I wrote my equation correctly. So now I have my value of 11.7x plus 120.8, and that is my linear regression line. My r value that I'm going to be looking for here, we're not going to be using r squared. We're only going to be talking about the r. This is your correlation coefficient. So you have 0.8827, and that's going to be our value. And we're determining whether it's a strong correlation, weak correlation, or a no correlation. Since it is getting closer to a positive 1, we will have a positive and a stronger correlation. And I will go over that when we talk about it in our actual problem. So if we look at our slide again here, so we see that we have our example continued, and we're going to be using this equation to find the projected year that they will profit from for $226,000, and we're going to round that to the nearest whole number. So I want to double check real fast what my profit is actually my y value. So I'm going to be plugging in that $226,000 for my y value. So let me go ahead and share with you guys how we're going to be doing that. Okay, so if we have our equation y equals 11.7x plus 120.8, I am now going to be plugging in that $226,000 for my y. So I now need to solve for x, so I have 11.7x plus 120.8. We're going to go ahead and subtract the 120.8 so we can get the x by itself. Once we do that, we end up getting, of course you have to enter that in your calculator as well, or if you got it in your head, you're good to go. So now I have 105.2 equals 11.7x. I'm going to go ahead and divide both sides by 11.7. Make sure you guys are please showing me all of these steps in your own calculator, or sorry, on your own paper. And now I have 8.99, which I'm actually rounding to the nearest tenth, which that would actually round to x equals 9. So x equals 9 is not the actual answer because we're talking in years. We need to actually determine what the actual year is. So our problem says since 2014, that's what the years represent. So if we count 9 years from the 2014, then that will be our actual year that we got, that will make that $226,000. So in year 2023, that is our actual answer. So we have to use this value to add it to our years. So in 2023, they will make $226,000. So this is what we use our linear regression stuff for, because we can predict values by using those linear regression lines. Okay, so now we're going to be, that was our complete sentence for that first part of our example continued. Now we want to interpret the correlation coefficient using a complete sentence. So I'm going to show you guys how to do that as well. Okay, so we said that our R, so this is that second part of that equation. So I will be asking you what the actual correlation coefficient is, which our R is equal to 0.8827, which means that we have a positive, strong correlation between the number of years and the thousands of dollars being made. Okay, so that's how you would interpret your correlation coefficient, and that is all. We will be practicing this in class, and I'll see you guys soon. Thanks.